Um, well, I
Like
I just
starting
substituted.
with number 5.
I substituted um, two into the equation, then wrote down the answer I got. Then did the same thing with four. I'm sorry, with three, but then I wasn't writing down like the
Okay,
equations.
okay,
I was solving
okay,
them by
okay.
using
But
calculator.
when you are solving, like when you are showing, uh, there are there are 4 steps that you need to take note. When you want to show that this equation has a root between 2 and 3, you have to show the stages. Usually there are 4. Firstly, you have to indicate your function, saying f of x, right?
Yes.
So your f of x is taking all the variables to one side, like taking these variables to the other side. You get what? 2x, you get 2x squared minus 5x, right?
Yes.
Then plus 1, right?
Yes.
Then we are required to show that there's a root between 2 and 3. So your next step, you are going to substitute f of 2. We need to see your substitution, where you are going to substitute 2. So it's 2 times 2 squared. So it's part and parcel of the working, whereby you are going to get all your method marks. Then plus 1 here. And what do you get?
Minus one.
Minus 1. And you can indicate that minus 1 is what?
Negative.
It's negative. Then you do the same. f of
Three.
f of 3. You are going to have 2 times 3 squared minus 5 times 3, right?
Yes.
Plus what? Plus 1, right?
Yes.
Then your answer will be what?
Four.
4. And 4 is what?
Positive.
It's positive. Then after this, you are going to give a comment or conclusion. Again, it's a mark. So if the question is saying maybe it's 2 marks, you'll be given 1 mark for indicating the substitution. There will be mark for indicating the substitution. Maybe seeing that your f of 2 and f of 3 is what? It's positive and negative. Then there will be a mark for comment. Please, you have to state the comment. What's the comment? We said you'll be saying, since there is a change of sign, that is negative and positive, it implies that the root lies between what? 2 and 3. That would be a comment. Saying, since there is a change of sign, it will imply that the root lies between what? 2 and what?
Sure.
2 and 3. Right? That is if the question have got 2 marks. 1 mark is for the substitution and the other mark is for the comment. And if you are given 3 marks for this, the other mark will be indicating the value of f of x. That are you able to identify your function? Say mark. Then 1 mark for substituting all of this. Then another mark for commenting. If there are 3 marks. Right?
Yes.
So in the exam, when they are asking you to show that there's a root between 2 and 3, These are the procedures, the layout that you are supposed to do. Then you have all your marks. So the way you present your work, I don't think there will be no mark for that, because there's no indication of saying this one is f of x. There's no indication of saying this one is f of 2, and there's also no f of 3, and also no comment. So make sure when you are writing this is the layout. Yes.
Yes.
Okay, fine. So the next was number 6. Was there a change of sign there?
Yes, there was.
There was a change of sign. Then the next was number what? 8.
Yeah, there was a change of sign.
Yes. What about number 7?
There was also a change of sign. There was a change of sign for all of them except for number 10.
Oh, number 10 has got an error. I just want you to emphasize on number 7 and number 12. If you look at number 7 and number 12, or maybe your calculator was already in radians, when you have like in this case we are saying we have x as the power and x as the angle, isn't it?
Yes.
Here x is defined differently. Here x is an angle, here x is a power, which is a number. So if x is defined differently, your calculator should be in radians. Was your calculator in radians?
Yes, it was.
Yeah. So whenever you are finding a change of sign and you have trig, make sure your calculator is in radians, because usually most of the students fail to identify it. Then they will say, yeah, there was no change of sign because everything gives negatives or positive, simply because their calculators were not in radians. Right?
Yes.
Right. So this method is what we call the method by calculation or a change of sign. Right?
Yes.
So we are now moving on to the second method. Have you drawn the standard graphs? I didn't see the standard graphs.
No.
Did you manage to get anyone?
Yes, I do have them.
Okay, can you send me? I just want to verify. Can you give me about 5 minutes? We have
There's the one that passes through the. Oh, let me just check which image it is. It's on the first image.
Yeah, for yeah, these are the general, yeah, of y equals to x cubed. Yeah, it's correct. This one is the general graph of y equals to x cubed. This one, right? Perfectly. I was just asking the one just below y is equals to x cubed. This one is the general graph for y equals to x cubed, right?
Yes.
Yeah. Then for the exponentials, yes, they are okay, they are correct. But you were supposed to just separate them. It's okay. You have just combined them. It's okay, still fine. But next time when you are drawing the graph of e to the power of x, just it's just like this. It cuts at what? At 1, isn't it?
Yes.
Then for the negative, e to the power of negative, it will be like opposing, like in this direction, right?
Yes.
E to the power of negative. Then for Linux, yeah, Linux it's correct. It also cuts at 1 for Linux. The graph for Linux is also correct. Like this shape, it's okay. It cuts at 1 here. Right, then for the one or for x squared now, the graph for x squared, the general graph for x squared, just wanted the general graph for the x squared, because that one I don't think so. It's the graph for x squared, because we'll be saying when x is equals to 0, what will be y? If we are saying y equals to x squared, if x equals to 0, then what will be y?
0.
It's 0. So it passes through the origin. So it will be something like this. The shape is correct, but where it passes, so here is the graph of y squared here. Y is equals to x squared, this one, right?
Yes.
So it passes through the origin. This is the graph of y is equals to x squared. Just the general, we wanted the general. Then you said you didn't find the graphs for what?
Y is equals to 1 over x.
Yes, the graph for y is equals to 1 over x. The general graph is this one. And here we have this pattern, like this one. Yes, like this. This is the graph. Yes.
Yes.
Yeah. Do you still have the other one?
For y is equals to x.
Y is equals to x.
Yes, well, I know what it looks like though. It's a straight line passing through the origin.
Yes, it's a straight line which passes through the what? The origin. This one, it's y equals to x. It passes through this origin. Right?
Yes.
Yes. Your y is equals to x. So these are the general what? These are the general graphs. So if you know these standard graphs, you are now able to locate roots using graphical method. Suppose we were locating roots using change of sign, but in this case they may ask you to indicate or to state the number of real roots using graphical method. So maybe you can write locating roots using graphical methods. You can write locating roots using a graphical method, right?
Yes.
Right. So let's start with a simple example from the graphs that we were sketching. Can you write show graphically? Can you write this example? Show graphically that the equation x is equal to 1 over x has two real roots. Show graphically that the equation x is equals to 1 over x has two real roots. Right?
Yes.
So before, yeah. So as you can see, this equation, hello?
Like, is it supposed to be x or that should be a y?
No, it's x is equals to 1 over x.
Okay.
Yeah. It's just a simple equation. I just wanted to highlight to you something. So they're saying that show that this equation has got two real roots. Right?
Yes.
So as you can see, this equation, we have this, we can split this y. So we are going to draw the graph of y is equals to x. Right?
Yes.
And also the graph of y is equals to 1 over x. Right?
Yes.
And see what happens to this graph. So they are saying show that there are two real roots, meaning to say the two graphs, they are going to intersect twice. So if the two graphs intersect twice, it implies that there are two real roots. So we'll be saying you now know the graph of x, y is equals to x. Yes?
Yes.
It passes through the origin. So let's say this one is the graph for passes through the origin. The graph for y is equals to x, right?
Yes.
Now let's go and draw the graph of 1 over x. You now know the graph for 1 over x. It's this one. And this one. So as you can see, the two graphs, how many times did they intersect?
2 times.
Yes. So it indicates that there are two real. So you draw these graphs. So if it was a question, let's say, so this one will be the root and this one will be the root. So suppose there are 3 marks. Here is the mark allocation for that. If you draw one of the graph correctly, you will have 1 mark, right?
Yes.
Clearly indicating the intercept. And if you draw the other graph correctly, you will get another mark. Then the other mark is for comment. Again, you have to comment. What will be your comment? Like, it will be saying, since the two graphs intersect twice, it implies that the root lies it implies that there are two roots. Your comment will be, since the two graphs intersect twice, it implies that there are two real roots. That will be your what? Your conclusion.
Yes.
Right?
Yes.
So when they are saying show graphically that the graph shows maybe 1 or 2 roots, make sure you indicate your x-axis and your y-axis, and also show where the graph cuts. The intercepts, they are very, very important. You have to indicate the intercepts. So after that, you have to comment. If the graphs are intersecting twice, we have two roots. If the graphs on intersecting ones, you've got one root and so forth. You have to comment. Yes.
Yes.
And also for this one, let's look at number 9. We want to look at number 9. They are saying show graphically that the equations below indicate the number of roots. So number 9, we want to show that this equation, it indicates what? There are two what? There are two roots, right?
Yes.
So here, let's say we have two. We want to draw two standard graphs here. For number 9, we are going to draw the graph of what? Of y is equals to what? Ln x, right?
Yes.
And also the graph for what? For y is equals to g?
1 over 4x.
1 over 4x. So let's say we have this. Let's say with this plane, so make sure you have to indicate all your x. We are just sketching, but make sure your sketch clearly shows the intercepts. So for the graph of Ln x, here is the correct shape. Again, we consider the correct shape. So it's it approaches this one with this. This one is the graph for Ln x, and it cuts at what? At 1, right?
Yes.
So this one is the graph for Ln x. Right. Then we also have the graph for quarter x. But this one was not amongst the standard graphs. But it's similar to, it's just we have this x, this multiplying by quarter here. So it is going to take the shape for y equals to x, but it's not general y equals to x. So for if the coefficient of x, if the coefficient of x is a fraction, the shape will be something. Okay, let me use it different. So for this, the shape will be something like this one. So if we have a fraction, maybe 1 over bx, right?
Yes.
That will be the shape. Like in the case we have got quarter. If the coefficient is a positive integer, again it will have the same shape, but the graph will be on top of the original graph of y equals to x. Like this graph will be y is equals to bx. So we will be playing around with the shapes. Here it will be a positive integer, like the graph of y equals to 3x, where 3 is a positive integer multiplying with the x. So the graph will be in this form. And for a fraction, it will be this form. Or they pass it through the origin and they take the shape of y equals to x, right?
Yes.
So let's draw. Let's try to draw here. Okay. So it will be something like this now. For quarter, let me just, right? So this one is the graph for y is equals to quarter x. Are we together?
Yes.
Okay. So as you can see, as a comment, you are going to say, since the two graphs intersect twice, it implies that they are what? They are two real rows. Yes?
Yes.
Yeah. So that's the presentation. Mm, can you try number 11? Can you try number 11? Maybe let me give you just 2 minutes. Just 2 minutes. Or less than 2 minutes. Number 11.
What made just this one for ln x plus x minus 4?
Yes. How did you tackle it?
Um, I was trying to find out where the graph crosses the x-axis by making an equation where ln x plus x minus 4 is equal to 0.
Okay. Okay. So did you split this equation?
No.
You didn't. Like if you look at number 9, the equation was splitted. Here's the equal sign. We drew this graph and we drew this graph, like what we have indicated earlier. But as you can see, number 11, all the variables are in one side, and we don't have a standard graph like in this form. So we have to split this equation into two graphs that the standard graphs, like Linux. So let's split this equation and rewrite it as what? Let's say it will be like ln x, because we know the graph of Linux, isn't it?
Yes.
Ln x is equals to, then we have to take this remaining to this side. So we are starting with the positive, so it will be 4 minus what? 4 minus x, right?
Yes.
Right. So we are going to draw the graph of y is equals to ln x. And here it's not a standard graph, but it's just simple line graphs from O level. The graph of y is equals to 4 minus x, right? Isn't
Yes.
it? So now
It is.
we are doing our sketch here. Now we are doing our sketch here. Here is our origin. So firstly, the graph of y equals to ln x, it cuts at what? At 1, right?
Yes.
1 here. So this one is the graph of y is equals to ln x. Fine with this. Are we together for the first graph?
Yes.
Let's move on to the second. This one is a straight line. So to draw a straight line, we just need 2 points. You still remember the table values that you used to come up with if you want to draw a straight line graph. Maybe saying, let's say we have our x here, and here we have our y, where you say when x equals to 0, what is the value of y for this one? If x equals to 0, your y is going to be what? 4, right?
Yes.
For this line. So you have 0 and 4. Let's say this point it's 4. Then you can say again what happens if y equals to 0. If y equals to 0, what is the value for x?
It's 4.
It's 4. So if y equals to 0, our x is going to be 4. Right?
Yes.
Then we join the 2 points. That will be a straight line. So this is the line y is equals to 4 minus x. So as you can see, the two graphs intersect what? It intersect once. Here will be our root. Right?
Yes.
Yeah. So next time if you are given just an equation which has got only variables to one side, you are supposed to split into two graphs that maybe if one is a standard graph like Linux, you know how to draw Linux, then you draw it. Then the other one will be easier, like straight lines, as you can see. Right?
Yes.
Yeah. So maybe if you can you copy down these numbers? Let me see if I can you, as part of your homework, can you do these numbers? Maybe if you can take number 4, number 6, number 10, and also number 8, these 4 questions. If you can take them down.
So it's 4, 6, and 10.
Yes, 4, 6, 8, and 10. 4, 6, 8, and 10. Are you done?
Yes.
Okay, fine. So under this topic, we are now we've managed to locate the roots, but the remaining aspect is now approximating the root. Yes, we've managed to indicate maybe by calculation saying yes, our root is between 1 and 2. So the next thing here, we want to approximate that root. Yes, we will know that there are 2 roots, we will know that there is 1 root, but what is the value for the root? So that is the last aspect on this topic. So these 2 methods, we were locating the roots, maybe seeing if the root lies between 3 and 4. Yes, we have managed to show that the root lies between 3 and 4, but what is the value of that root? So our next concept, we are now approximating the root, the value of the root. Let me see the syllabus here. Let me move to the syllabus here. right? So we have managed to locate roots by a change of sign. We have do the means of a graphical. So we are now going to see an idea and use the notation for the sequence. If it converges to a root, we want to approximate the root, and we are going to approximate the root using iterative formulas. So the formulas will be given to find that root, and we are going to find that root to a prescribed degree of accuracy. So you can write a subheading saying approximation of roots using iterative formulas. Approximation of roots using iterative formulas. Are we together?
Yes.
Yeah. And I think here I have it because I don't have a calculator. You have to use your calculator over your side. I will be indicating where and when to use the calculator. Let me see if I have a straight question from a past exam question. Let me see if I can start with a question. Right, as you can see these graphs. Right, as you can see this question, it's a recent paper, May, June. Number 6, are you seeing this?
Yes.
By sketching a suitable pair of graphs, show that this equation quarter half x is equals to 1 plus e to the power of minus x is exactly one real root in this interval. Have you done trig graphs under trigonometry?
Yes, but only cosine and tan.
Cosine, sine, and tan.
Yes.
Oh, okay, fine. We'll look at that. And also, part B, verify by calculation that this root lies between 1 and 1.5. Okay, that one. Then the last part, the one that we want to do, use this iterative formula to determine to 2 decimal places, giving the result of each iteration. Which calculator are you using? Is it a right view?
Yes.
Okay, fine. It's okay. Let's try to see this paper again and try to see which one is easier to start with. Do we have this one? And do we have a function here? Yes, as you can see, this one is combined with these shapes. It's combined with shapes, trapezium, and so forth. And the equation in this case is this one. As you can see, there's this equation. As you can see, this one is the equation, right?
Yes.
So part A is on its own, is another topic, but they are now saying verify by calculation that x lies between this one. So we are now using by calculation, and also see if the sequence converges to this one, to this iterative, and after that we are going to use this iterative. So I think we can start with this one. Then from then I will give you question. Let me see the last component. Let me see the last component, if I, or is it the same? Right, as you can see, number 7, number 7,
Yes.
it's application of differentiation, where they are saying your m is the maximum point. You still remember maximum point dy dx equals to 0,
Yes.
and after that, using the concept differentiation, saying dy dx equals 0, this equation, you are going to see that they want you to show that a satisfy this equation. So we are going to have this equation, and we are going to obtain this equation through the concept of application of differentiation. Then after having that equation, they are now saying verify by calculation that a lies between 1.3 and 1.5. It's now numerical method. So numerical methods is a topic which you can find inside other topics, right? And after verifying, you are going to use the iterative formula to find the value of a, right?
Yes.
So I will give you these ones as homework, because you will be referring back to differentiation. Then you can try to come up with this equation. Then after that, you continue to numerical method. So let's start with this one. But in this case, I'm not going to do part A. Maybe you can try on your own for part A. I just want to demonstrate on how numerical methods is solved. So maybe you can have another day for part A. But please, you can do the part A. After doing that part A, maybe you can revise it tomorrow. This topic, it's under shapes, circular measure, and so forth. Right?
Yes.
But under exam questions, suppose you have failed to prove or to show this equation, it doesn't mean you cannot do part B and C, because part B and C and D is purely numerical methods. Here will be our equation. We will have the equation x is equals to x is equals to 0.9 2 minus cos x. That is the equation. We are going to start at this point, because this is the equation that we want to deal with, right?
Yes.
So they are saying that verify by calculation that x lies between 0.5 and 0.7. So we say the first procedure, you have to make your function f of x. by taking everything to one side. We have more terms to the right side, so let's take the term on the left hand side to the right hand side. So if we say our f of x is 0.9 open bracket 2 minus cos x, then sine x, then if we take that x to that side, it will be minus x, right? Are we together on this one?
Yes.
Right. Then the next step, let's substitute f of 0.5, and before substituting, make sure your calculator is in what?
Right.
In radians. So can you punch where there is x, put 0.5. Here f of 0.7. What do you get for 0.5?
0.48.
You get 0.48. Oh, sorry. Let me, okay. I don't know what is happening here. Okay. It's 0.48. And it's what? It's positive, right?
Yes.
For 0.7,
0.72.
do we have all positives?
Yes.
Is your calculator in radians?
Yes, it is.
The first one you are getting positive or negative?
It's positive.
What about the second?
It is also positive.
Are you sure?
Yes.
Where there is x, you are saying,
Oh,
right?
no, there's something I omitted.
0.9 open bracket 2 minus cos 0.5 close bracket times sin x minus 0.5.
Yeah, I hadn't subtracted x.
Oh, okay. So for the first one, is it correct or wrong?
Yeah, it's correct. It's negative 0.01516.
Negative 0.016.
0.016.
Something like this. Then you have to write all the values. Please write all the values. Then minus, so this one is negative, right?
Yes.
Then substitute 0.7.
0.016.
Okay, it's 0.016.
0.16.
So it's now positive, right?
Yes.
Yes. So we are going to comment. Can you write your comment? Since there's a change of sign, it implies that the root lies between 0.5 and 0.7, right?
Yes.
Yeah. And you have your 2 marks. 1 mark for comment and 1 mark for substitution. Are we together?
Yes.
Right. Then on part C now, we are now moving on part C, the one with the iterations. They are saying show that if the sequence of values in the interval 0 to pi over 2 is given by the formula, that formula, show that, yeah, we are showing that if a sequence of values between this is given by the alternative formula converges, we want to show that it converges, then it gives a root in the equation in part 1. This is the equation. So simply what we are doing here, we want to show that this formula comes from this equation. Then you only have your 2 marks. We just want to show that this formula, we have derived this formula from this equation, right?
Yes.
So this one is an iterative formula. So if you want to show that it converges, you can remove these subscripts. You can remove these subscripts, this subscript, and also this subscript, and also this subscript. Then you have which equation now? Then you are going to have x is equal to arc cos of 2 minus x over 0.9 sine x, right?
Yes.
Then after that, we want to arrange this equation, and if we arrange this equation, we must obtain this equation. So if we obtain this equation, then we've shown that it converges. So let's arrange. Here we have arc cos, right?
Yes.
Let's take arc cos to this side. If we remove arc cos to this side, it will be cos x, right?
Yes.
So it will be cos x is equal to bracket 2, right? Or we can just remove the bracket, or we can just remove this bracket. 2 minus x over 0.9 sine x, right? Are we together?
Yes.
Then after that, what are we going to do? We want to have this one, this equation like this. Which x are we now going to make? We are going to make this x the subject, right?
Yes.
Right. So let's take this one to this side and this one to this side. So if these whole things come to this side, it will be positive, right?
Yes.
Then here we have 2. Then if you take cos to this side, it will be minus cos what? Cos x, right?
Yes.
Then we want to remain with this x. We are going to cross multiply, right?
Yes.
So it will be 0. Here it's our x, here it's x. So it will be 0.9 sine x bracket 2 minus cos x, right?
Yes.
And if we can, have we reached, is it the same, this one, is it the same as this one?
Yes.
Or we can just take this sign to this edge, you still have the same result. So it's 0.9 here, then we have 2 minus cos 2 minus cos x sine x. So it converges, we have shown it. Yes?
Yes.
Yeah. So we get our 2 marks. So it's just to remove the subscripts, then you have that equation, then you arrange it to obtain the original equation. Understood?
Yes.
Yeah, fine. Then the last part on D, they are saying use the iterative formula to determine x correct to 2 decimal places. Give your result in each. Right. So this one, the ones with the subscripts, this one, it's our iterative formula. Let me enlarge it. This is the iterative formula. Are you writing somewhere?
Yes.
Okay, because I want to delete this one. Let me delete this space. So now we want to approximate that root. So initially we have said the root lies between what? We have said the root lies between what?
0.5 and 0.7.
0.5 and 0.7. It's lying between 0.5 and 0, and we don't know that value, right?
Yes.
So our ideal first approximation is going to be a number which is between 0.5 and 0.7. So that will be our first approximation. Which number lies between 0.5 and 0.7? Or maybe you can add 0.5 plus 0.7, then you divide by 2. What do you get? Number between 0.5 and 0.7. It's what?
0.6.
0.6. So it is going to be our first approximation. So 0.6 is going to be our first approximation. That is if you are not given the first approximation. Right?
Yes.
So if you are not given the first approximation, you are going to take the middle value. So let's go and find that root. So it's to 2 decimal places, but each iteration we are going to give it to 4 decimal places. So let's substitute. So if you want to find x2, the second approximation, right?
Yes.
You are going to say it's arc cos. Make sure your calculator is in radians. It's arc cos of 2 minus, where there is xn, you are now substituting this value, 0.6 over 0.9. You said you are using a right view, right?
Yes.
Yes. A sine 0.6. So can you punch this one? And I want the answer correct to 4 decimal places. Let's have the answer correct to 4 decimal places.
Zero point 610.
0.6
106.
to 4 decimal places, right?
Yes.
So this one is to 4 decimal places. Then at the end, let's write it to 2 decimal places. So it will be 0.61, right?
Yes.
Then if we want x3, we are now moving to x3. we are now using what? X2. So if you are using a right view, just go and delete 0.6. Where there is 0.6, you substitute this one with 4 decimal places here. Did you get it? Hello?
Yes.
Yeah. Go and substitute the value with 4 decimal places. Where there is 0.6, say a cos of 2 minus 0.6106 divided by 0.9 times sine 0.6106.
0.6151.
0.61151,
151.
right?
Yes.
Then at the end, let's round it to 2 decimal places. You have 0.6 what? 2. And if you compare these two answers, they are not yet equal. They are not equal, right?
Yes.
So you do again the other iteration until these numbers are equal. So now let's find x4.
0.6170.
It's like you are now substituting this one in this one.
Yes.
You get
0.6170.
0.6170, right?
Yes.
Then if you round it to 2 decimal place, what do you have?
0.60.
Yes. And now the numbers, they are now the same, right?
Yes.
Then we stop the iteration. Then we will have the answer. That will be our answer until we have these 2 consecutive numbers being equal. So the value of x to 2 decimal places is what? It's 0.62, right?
Yes.
So that's how we find all the um, roots. That's how we approximate the roots to a prescribed the one they're saying to a prescribed degree of accuracy. Like in this case, the degree of accuracy was 2 degrees, 2 decimal places, but our iterations were giving correct to what? To 4 decimal places, right?
Yes.
So don't forget to put the 4 decimal places into the original, not these 2. Yes.
Yes.
Okay, so I think for today let's end here. Let me try to give you, or you can download this. Can you download these question papers? You can.
Yes.
Let me give you the codes. So this one is for May June 2021, component 33. You can write down the code, right?
Yes.
And it's number you're supposed to do number, oh okay, number 6. I want you to try this one for code. You can research, it's okay, we will do it tomorrow. But if you are, but you can do B, where you are going to use this equation to verify, right?
Yes.
Then you are also given this iterative formula, part C. Where is my, okay, think my wait a second, my machine is not responding. Right, fine. Will number okay. I think I pressed internet here. Hello? Lutendo?